Solve for x in R. A. 4 to the power of x is equal to 2 to the power of 3x plus 2. B. Log base 8 of x plus 2 plus log base 8 of x is equal to 1. A. 4 to the power of x is equal to 2 to the power of 3x plus 2. So I have to solve that for x real number, which means basically that I need to do some working until I can get to x equals, and then that will be solved. So I need to get these x's out of the powers up here and down onto the bottom line so that I can get x equals, which means somehow I need to cancel out this 2 to the power of, or this 4 to the power of. Well, that's okay because I know a function that does that. It's log base 2. Log base 2 is the inverse of 2 to the power of, and they're designed to cancel each other out. So if I do log base 2 on both sides of this equation, it will cancel out the 2 to the power of. Log base 2 of 4 to the power of x is equal to log base 2 of 2 to the power of 3x plus 2. And being inverses, log base 2 and 2 to the power of, these two here, will cancel each other out, and I'll just be left with 3x plus 2. And now I just need to know what to do with this over here. The log base 2 and the 4 to the power of are not going to cancel each other out, so I need to use some other law of logs to help me out. And there is a law of logs that says when there's a power inside the log, I can bring it out the front, like that. So this would be equal to x log base 2 of 4. Alright, well now I need to know what to do with this log base 2 of 4. Well, log base 2 of 4 would be whatever power I would need to raise the number 2 to get 4. So the question log base 2 of 4 is equal to what is the same as the question 2 to the power of what is equal to 4. And I know that 2 to the power of 2 is equal to 4, and therefore log base 2 of 4 is 2. But I can get there slightly longer by thinking about it more slowly. 4 is 2 to the power of 2. Like that. And so the log base 2, the log base 2 and the 2 to the power of 2, the log base 2 and the 2 to the power of will cancel, and this will all become 2. So I get x times 2 is equal to 3x plus 2. So 2x is equal to 3x plus 2. And now I have an ordinary linear equation which I can solve. If I take this 2x over to the other side, subtract it from both sides that is, I'll get x here. And if I take this 2 here over to this side, the left-hand side, so subtracting 2 from both sides, I'll get negative 2. So x is equal to negative 2. And I can just check my answer. Check. 4 to the power of negative 2 is 1 over 4 to the power of 2. That's what the negative means. It means put it on the bottom instead, which is 1 over 16. And 2 to the power of 3 times negative 2 plus 2 is 2 to the power of minus 6 plus 2, so 2 to the power of negative 4, which is 1 over 2 to the power of 4, which is 1 over 16. So it does work after all. So finally, therefore, x is equal to negative 2. Now for part B. Part B was log base 8 of x plus 2 plus log base 8 of x is equal to 1. Now, I could cancel out the log base 8 in the same way that I did in the other question by doing 8 to the power of. So if I did 8 to the power of both sides, 8 to the power of, and 8 to the power of 1, I could possibly cancel out these logs, but there's an addition up here, and that doesn't look too easy. So I just think I won't do that after all. Instead, I think I'll use my laws of logs to join these two logs into one log, and then I can do 8 to the power of. So my laws of logs tell me that addition here outside or between two logs becomes multiplication inside the logs as long as the two bases here are the same, which they are. So this is going to become log base 8 of x plus 2 times x is equal to 1. And that there is an equation I can solve. Let me just expand it out first. Log base 8 of x squared plus 2x is equal to 1. And now I can do 8 to the power of both sides like this. So when I do that, the 8 and the log base 8 will cancel each other out because they're inverse functions, and that's what they're designed to do. So over this side, I'll just end up with x squared plus 2x. And on the other side, 8 to the power of 1 is 8. Now I don't actually need to do this 8 to the power of on both sides. My reader will understand perfectly well, so I'll just get rid of it. And now I have a quadratic equation to solve. So x squared plus 2x minus 8 is equal to 0. And to solve a quadratic equation, generally you factorize it into two pieces like this, with an x in both of them. And the numbers that go in these positions here and here will have to multiply to give negative 8 and add to give 2. So 2 and minus 4 multiply to give negative 8. But they add to give negative 2, so if I use negative 2 and plus 4, negative 2 times plus 4 is negative 8, negative 2 plus 4 is plus 2, which is this number here, so that factorized correctly, so therefore x is equal to 2 or negative 4. So let's just check our answers. So check log 8 of 2 plus 2 plus log 8 of 2 is equal to, well, that's log 8 of 4 plus log 8 of 2. Log 8 of 4 plus log 8 of 2, which using that law of multiplication again is log 8 of 4 times 2, which is 8, which is 1. So that one works. Log 8 of 2 minus 4 plus log 8 of minus 4. Oh, that's a problem. I can't do log of a negative. So this is actually undefined. Is undefined. Which means that my minus 4 isn't actually a solution, so therefore x is equal to 2. And that's the end of the problem.